Good morning, good evening. My name is Nick Narzinski with D3 Technologies. Welcome to part 3 of our Advanced Manufacturing webinar series. Today we're going to take a look at the power of 5-axis with PowerMill. If you missed the first two, they should be online as well. The first one we took a look at the extensions within Fusion 360. And in the part 2, we did advanced turn mill applications with FeatureCam. And so now let's take a look at PowerMill. So what is PowerMill? PowerMill is expert CAM software for the mold, die, and highly complex 5-axis applications. It is a dedicated software for milling, used by experts and trusted by their peers. We have exceptional quality within vortex machines. That's your high-speed machine or high-efficiency roughing. However, there's many different terms for that. Adaptive clearing, that you've probably heard of before as well. 2D milling applications, so your simple pockets, holes, contours. 3+2 machining, so indexing the tool axis at different angles and locking that in, and then milling features. True 5-axis milling, SWARF toolpath axis controls. We'll go over where that's available inside the software. And then mill turn applications for doing simple turning applications on the mill. And we also have another product for doing robotics with milling, trimming, and different areas there as well. And finally, we have a lot of automation built in here to record yourself doing macros so that you can reuse workflows from part to part. So its impact in improving precision and quality with high quality toolpaths and be able to distribute points evenly. By doing that, we're able to eliminate or remove manual polishing, meet delivery schedules, and win more high-value business. So we're getting increased precision by being able to go in there and really edit just about any toolpath to do anything that you want, while also giving us excellent surface finish with our excellent CAM kernel to generate very smooth toolpaths and do that very efficiently. We can do that efficiently with the use of macros or with the use of different areas of the software to speed up the programming time, as well as the machining time. With that, we have a greater control and flexibility, reduced cycle times, repeatability, and standardization, and we can maximize the return on investment for that CNC control, machinery. So where does our trust come from? We have full stock simulation to verify toolpaths, collision and check and avoid. We can do that on the fly as we generate our toolpaths. And then we can verify entire projects when we're done to make sure that there's no issues before we go take that code to the machine. Doing that, we increase confidence in our ability to take that code from the software into the tool. Better use of our workforce, protect hardware investments, and reduce machine downtime. All right, so here's what we're going to focus on today. Is what 5-axis toolpaths are available, how to edit those toolpaths once they're created, using axis control to tilt the tool to get efficient results, and then toolpath verification to add confidence and verification that what we're simulating and what we're programming is going to run the machine without issues. PowerMill has a very comprehensive list of toolpaths. There's a vast library of finishing strategies that give us a lot of flexibility. Steep and shallow is probably the #1 used toolpath for finishing the software. It combines strategies for steep and shallow surfaces defined at a specific angle that you define. And then being able to use rest finishing strategies to go in there and clean up the little details that we might have left behind from a larger tool. Using 3+2 as an option to go in there, you can literally create an angle just about anywhere on there with work planes to drive toolpaths at certain indexed angles on the machine. Reducing setups, creating extending tool life, and getting parts done faster. Multi-axis machines, so true simultaneous 5-axis, we're able to get smooth motion with multiple tool axis options. We can see the tool vectors here on the right side, showing how smoothly those are distributed. And then combining the full suite of tool types for increased programming flexibility and extreme levels of surface finish. And we also have the ability to go back after the toolpath is generated, instead of having to go in there and tweak every little detail to what we need, which there's cases where that's going to be necessary, but we also have the ability to, if we see something we don't like, we can go in there and edit that toolpath directly, like removing certain lines that are extra that we didn't need, or changing a linking. All that is calculated independently of the actual toolpath. And then 5-axis optimization. Take control of your tool and how that's going to go in there and clean these parts up. Being able to analyze the tools with verification on the axis control and the smoothing from transitions from angle to angle. Simulation and verification. So we do have a stock simulation. We also have the ability to identify those problems early with that and see the effects of feed speed, number of teeth, and surface finish. Then on collision avoidance within each toolpath, we can do this for entire projects or individual toolpaths. Remove hazardous moves. We can break those hazardous moves up into separate toolpaths. We can have a different set of settings for one versus the next. And then using just automatic collision avoidance as well. Simulation and verification of machine limits. So you can go in there and see what the machine limits are, verify that your part can reach all the different areas that we have programmed with machine simulation. All right, let's jump into the software. Turn this toolpath off. Okay, so here's the part that we're working with. First thing I'm going to take a look at is collision, verifying the toolpaths. So here I have this finishing strategy added. It's a Z step down finish. And if we look into the settings of this, constant Z finishing. And so within there, we have different options for automatic verification, as well as doing automatic collision avoidance within inside the toolpath. So one thing I want to point out before I get into that is we have a visual here right inside of our Explorer. With white, it's saying that the tool is not necessarily gouged and collision checked with that white background and the check mark. Blue means it is all safe. So if I right click on this toolpath and go down to verify, here I can, actually, before we do that, let's just simulate this. All right, so right now it's just a standard 3-axis toolpath. As it works its way down here into this corner, I'm going to slow things way down. And once we get down to this corner, we'll see that the toolpath just isn't long enough and our holder starts to collide with our part. I think you can see where that's heading. So to get around that, we could do a few things. First thing, I could duplicate this. So let's just go into the settings. So it's going to bring up the form for that toolpath, and then I can select this button to create a dual path based on this one. So basically duplicating that. And then I can go down to my automatic verification, check that box, recalculate it. It is now going to run that toolpath through. And as you can see down here, it automatically removed the segments. If we compare it to this one, you can see where it went down there. It wouldn't have been safe to do so. And this one, by turning that on, it removed those unsafe segments. You can see some more back here. So then we can follow that up with a tool that might be longer and do rest machine or something along those lines. But let's say we have 5-axis capabilities like the Okuma MU400VA has. Another option we might do, let's just go back in there. duplicate that again. This time we're going to look at the tool axis tab and we're going to turn on automatic collision and avoidance. And we want to do this based on vertical. And yeah, we'll do lead then lead. And I need to turn off my high speed flip corners. So let's calculate that one. Now you'll see we go back to our toolpath that we had originally, but this time it's going to tilt that tool in those areas where it would have had collisions if we only ran this in 3-axis. And another option we could do is right click on the original source file. And let's just edit this real quick. All right, I'm going to change my step down value. Let's recycle this toolpath. We'll make it 1.5. Calculate that. Now I'm going to right click and go to verify. This time we're going to look at the toolpath verification on that toolpath where I can say look for collisions or look for gouges. And when it finds those, what do you want it to do? I can split that toolpath to where we can see it broken out into the ones that were safe with this toolpath, and then they'll have another toolpath for the ones that weren't safe, so we can add a different tool. Down here it's saying let's just adjust that tool for the second version, or where there would have been collisions. We can also have it split up moves and create an overlap between the two. So we got a lot of different options here as far as how we want to handle that. So let's just apply it. Here on the left side, you'll probably see the browser or the Explorer, break that into multiple toolpaths, and then we get verification here saying the collision with the shank at this depth, we had this issue. And so what it did was it edited the overhang angle of the tool to avoid that holder with colliding. So we can then accept that. And now you can see we have it broken down into 2 separate toolpaths that we can then go in and apply different settings to. Have one with the more rigidity using the shorter tool, and maybe switch to another tool, or maybe start adding a tool tilt with just this one where there would have been collisions otherwise, and still use a shorter tool. So we got a few options there as far as how we want to handle that at that point. But that toolpath verification gives us a lot of options. All right, next thing I'm going to look at is on this one, again, our tool along this extrusion right here, our tool doesn't stick out far enough to reach down into this corner. So this is corner remachining or corner finishing. We're coming in and cleaning up what was left behind from our roughing and our finishing strategy with maybe a larger ball mill. So again, I'm going to edit this. And I want to copy that. And let's just change, maybe I only want to finish the bottom edge here and by itself in one toolpath. So I'm going to go to my limits and add a maximum Z and just select this edge right here. And let's turn on automatic collision avoidance based on vertical. And we'll do lead then lean again. Let's calculate that. So we're telling it we can only start the toolpath down here at this height of this step, basically. It's just an easy way to eliminate all those other passes that I had. So here it's looking at all the different areas to avoid collisions. And it's going to apply that lead and lean with a smoothing distance of 24 millimeters. So smoothing is basically, I'll get into that here in a second, but that's going to take a look at how far it transitions the tool tilt. done. Almost there. Okay, so we finally finished calculating that, and so what we have now is it does tilt where we would have those collisions. So let me just double click here. So we can see that tilt with our clearance on the holder to the part. And so now what I want to do is, well, let's simulate this from the start. You see we just have a lot of rotations on the A and C, and we get this message saying a retract and reconfigure is required. So we get a lot of extra rotations that is going to be a little bit more difficult to maybe get the best finish that we want. So maybe I want to come in there and lock one of my axes at a certain angle and then just tilt the other to get the same basically the same thing done, or same collision avoidance done. So this time I'm going to edit that. And instead of doing automatic, and actually I want to maybe just look at one of these down here, simulate from here, and let me look at my machine tool. And here I can see I'm tilted to 16 degrees on my axis. So to be a little bit safer, maybe I'll go 20 degrees and lock that in. So to do this, I'm going to recycle that toolpath so I can make edits, come to my tool axis tab, uncheck automatic, do lead and lean this time, and let's do a lean rather, of 20 degrees from not contact normal, because that would be all the surface normals, but from vertical. So 20 degrees from vertical. Recalculate that. And now let's simulate that from the beginning. This machine needs a retract configure to be added, but now you can see that that A axis has been locked in at 20 degrees and everything's being done with the C axis. It's a little bit less work for the machine, probably give us a better surface finish, and a little bit easier for the operator to see what's going on as well, giving him a little bit more confidence in his abilities. Okay. Last thing I wanted to look at is the ability to use smoothing as it does its transitions. So down here, we have this toolpath along the wall, and with no smoothing, so if I look at the settings of this one, and come down to my tool axis, collision avoidance, I've got a smoothing distance of only 5 millimeters. So if we simulate that, you can see there's some very sharp adjustments being made. Actually, that's still the old one, my mistake. Simulate this one from the start. There you can see it's pretty right across that surface there. It's a pretty quick transition to do that tilt. So again, to get a better surface finish, maybe we want to make that transition occur over a longer distance. So that's where we can come in and do change the smoothing. This one was done to 20 millimeters, and this one's done to 50 millimeters. Let's simulate this one from start. Now you can see it's already started. And that transition goes across almost half the part now, as opposed to being a sharp, abrupt change in direction. as a toolpath tilts off of that surface. So with PowerMill, you really have unlimited amount of control as far as how that tool comes in. We haven't even looked at 3+2. Maybe we'll do that in another webinar, being able to create work planes and drive the different angles that you want to on a specific toolpath. But this shows a lot of the power in our simultaneous 5-axis toolpaths. So those are just a few different methods. If we look at as far as what toolpaths we have to offer for 5-axis, if we go to our toolpath strategy selector, all of the finishing strategies like in PowerMill have the ability to do 5-axis. One of the most popular ones, as I mentioned earlier, a steep and shallow finishing. Let's just select that. And with that same 12mm ball, looking at this model in 3-axis, so we got a threshold angle of 30 degrees. Let's put maybe a 2mm overlap between the two passes. But with that, and turning on our verification, and selecting our tool axis to be automatically collision avoidance. We could just about finish this entire part as far as finishing goes in just that one toolpath. Where'd it go? All right, let me try one more time. I had that toolpath selected. So we're looking at the entire block. So remembering my settings from the last time I just generated. Collision avoidance, turn this on. Let's do just lean. Let that calculate. There's also the option to add queue, so you can throw this toolpath in the queue if you want to continue working. Why are you doing that? It's because I've got that folder activated. This should take care of it. And I've got a limit turned on. All right, 12 interval, tool axis, vertical, auto collision. That's turned on. There it goes. So now it's calculating the steep first, and then it'll come back and add the shallow toolpaths to the rest of the surfaces. So between this roughing strategy, this rest roughing, and the steep and shallow, we could pretty much finish this part from that 3-axis, or from the top down, in just one toolpath. Obviously, it's going to tilt and do all the things we showed earlier on those areas where that toolpath couldn't reach. But other than that, you just come back through with maybe some quarter remachining to clean up the rest of the corners. 4 toolpaths, you've got a pretty good part that you can quickly program. And with the use of macros that I mentioned earlier, you're able to record how you add toolpaths. So if you do a lot of similar parts from one to the next, you record that workflow, reuse that on other parts as well. So hopefully that shows you some of the power of 5-axis inside of PowerMill, and I look forward to talking to you guys next time. Thanks.